Hey everybody, this is Mike. Welcome back to the shop. I'd like to, actually first of all I'd like to apologize. I've got the fans going. It's hot and humid here in northern Utah. It's our monsoonal time of year, so I've got the fans going in the shop, so hopefully you'll be able to hear everything okay over that. Anyway, I wanted to do a video. I haven't done one in a while, and the wife and I, it's getting that time of year when we are preparing for our marathon of Jeep rallies and gatherings coming up here with our RVing and Jeeping friends and group. So I think we have 4 week-long Jeep rallies or gatherings coming up in the next 3 months. So I've got a list of maintenance items to do on the Jeep, such as just as I keep track of things as I go through my normal routine lube oil filter services every 4,500 miles or so. I got a list of things like I need to rebuild my shocks. I need to, the rear brake pads are getting down a little bit, so I got a new set of pads sitting on the bench. I've relocated my rear shock mounts, so I have a little bit longer limited straps to throw on the rear. Give me another just about 2 inch, about an inch and a half of droop out in the rear. So I've got a list of maintenance items, plus this is also the time of year where I usually go through and change the fluid on the transfer case and drop my drive shafts and give them a good once over, in addition to the normal, like I said, the normal routine maintenance items. So anyway, I've got that list of regular maintenance items, but I was getting ready to do just kind of a quick visual inspection that I normally do before every off-road trip, whether it be a weekend or a week-long trip or whatever. So I thought maybe I'd just do a quick video and show you kind of items that I check prior to taking it off-road. So with that being said, I kind of wanted to touch on why I feel it's important to become familiar with your vehicle. Take for example, if you're driving to and from work every day on the freeway or back secondary streets, you get a flat tire, you have something fail on your car or whatever, most help is a phone call away. First thing most people, I'm not saying everybody, but most people, the first thing they would do is reach for their cell phone, phone a friend or a local garage or a towing company, something of that nature. When you're in the back country, back off-road, especially if you're by yourself, now I don't condone going off-road by yourself, but I'm going to admit my wife and I do a lot of off-roading by ourselves. A lot of times when we travel, we are either traveling by ourselves in the motorhome and we want to go exploring off-road in the Jeep, or we are with people who don't have off-road vehicles, or that doesn't interest them. So we do a lot of off-roading by ourselves, and it's not ideal, but if we waited for somebody else to go off-road all the time, we would probably very seldom ever go off-road. So we understand the risks, we accept those risks, so I don't condone that, but you probably ought to be even more familiar with your vehicle, is kind of the point I'm making. So if you have an issue driving back and forth to and from work, like I said, most people would just pick up a cell phone. You get in the back country and have a problem, the cell phone's not always an option. It actually is seldom an option. Number one, cell reception. Number two, you're back in there remote, where are you going to be able to give accurate description of where you're at? You should be able to, but not everyone can. So I thought I'd just throw this quick video and explain kind of why it's imperative, or why I feel it's imperative that you know your vehicle. You don't need to be you can be a home DIYer, no problem. You can even be an ASE certified mechanic, even better. But you don't have to have any background or knowledge in automotives or automotive mechanics to just become affiliated and get a feel and know some common terminology and know some common things to look for in your Jeep. You get that feel for it, and it does save you money in the long run for a couple of reasons. Number one, if you have to take your vehicle to a shop to have something fixed, you drive into a shop and you say, the Jeep doesn't handle very good, or a Jeep wanders. That mechanic is going to start from ground zero going through that vehicle, because you're not really giving him much to go off of. And it could be a couple hours of diagnostics and troubleshooting. Now, I had one the other day. The guy called me and says, was very specific. He knows his vehicle. He's not a mechanic, but he knows simple things to check. And he knew this was beyond his realm of experience, but he was able to describe it to a T as far as the symptoms. I turn a corner and it slowly started progressing, and over a couple weeks time, I noticed I'd turn a corner, and when I'd go to turn back, it would either stay on course that it was on or overcorrect and overshoot. So that was very specific. I knew, okay, in my head, he's either got maybe a ball joint that's hanging up, a tie rod that could be hanging up, or more precisely, probably a U-joint in an axle shaft. He brought it by, we went for a drive, we were able to duplicate it right there, brought it back, racked it, put it up in the air, and bingo. Right U-joint had seized up in one of the crosses on one of the trunnions. I think that was about a 20-minute diagnosis, and we was able to, another night I was able to disassemble it, get it repaired, get him back on the road. So had he just dropped it off and said, here, have at it, he'd have been more money in diagnostics, and possibly, I don't know, maybe I'd have found more stuff wrong, maybe I'd have found stuff wrong that wasn't really the problem. So therefore, I go ahead and fix a couple things that I find, give it back to him. He comes back, says, it's doing the same thing. He's thinking I'm a piss poor mechanic when I'm thinking you did a piss poor job of explaining the symptom. I don't know your vehicle. So it can save you money in the long run if you get to be familiar with types of failures. There's wear items that fail, that progressively fail over time. Shocks being one of them, bushings, things like that, tie rod, ball joints. Or there could be catastrophic failures. You usually will know those right away. A track bar on the axle, that I can't begin to tell you how many of those I repair. That's a common failure. You're going to know when that fails because you can't control the front end of that thing. The vehicle's going to go where the tires are pointing, and those tires are going to point all over the place. Ripping a bracket off of an upper control arm mount on the rear axle, that's another common failure point on Jeep. So these things are catastrophic. When they fail, they don't get better, and they generally will take out other components if neglected. So I'm just going to show you some things to check so that you can avoid that. Things are much easier to address. Again, either you fix them yourself or you take them to a shop XYZ, whoever does your repairs, that's great. But at least you'll know what to tell them to, where to give them a starting point, and have an idea of what's kind of going on with your vehicle. So anyway, before I get started on an actual checklist, I'm going to go over to the bench and I'm going to explain a couple of things on these vehicles that will vary from vehicle to vehicle. Now, when I'm going to call this out Jeep. This vehicle is mainly geared towards Jeep because that's most of what I deal with. But this can go for any vehicle that you have, whether it be a Toyota 4Runner, a Dodge Durango, an F-150. They're all going to have similar components to check, but there's going to be some unique idiosyncrasies specific to that vehicle. Now, if you happen to have built or bought a vehicle that is highly modified, there's going to be a whole nother level of components that you need to check. And some you probably need to check more frequently and more precisely, because as we start adding lift, bigger tires and wheels, stresses are put on components that were not designed for those stresses. What's an example I can use? Okay, let's just say, for example, track bar bracket. Look at your stock JK or even JL or TJ track bar bracket mounted on the axle. It's usually probably maybe 10 gauge stamped steel, MIG welded on. You get some miles on, there's some fatigue cracks. Now all of a sudden you lift it, you've bought a bolt-on suspension kit, bigger tires and wheels. All those components are adding extra stress trying to keep that vehicle going straight down the road. Now, when one component fails, a lot of times the reason why another one fails is because the stresses that were focused around that component are no longer focused on that, and so those stresses will just be dispersed elsewhere to other components. And if you have a bunch of components that are at or near their designed stress points and you add stress to that, there's a high probability that one of those other components are going to fail. I look at it as every vehicle has fusible links. Fusible links meaning a component that'll fail before something else does. When you're beefing up parts, when you're beefing things up, a lot of times what you're doing is you're moving that fusible link around your vehicle. The goal is to always have something that's going to break before something catastrophic, or wear before something catastrophic, but that's not always, in real world, that's not always what happens. So keep that in mind as you're buying these suspension kits and things like that, and you're bolting them to factory components. Keep in mind that you've just added stresses to those components that need to have a little more attention paid to them. And then the other thing I advise people is either before you have a failure or when you recognize wear or a failure beginning to take place, that's the time to upgrade to better components. Track bar brackets being a good one, bushings being another good one. So things like that. So that's just things to keep in the back of your mind. So let's go over to the bench. I've got a couple of bushings that I want to show, rod end, and then we'll actually move on with the quick demonstration of the quick checklist. Now, this is just going to be a quick visual checklist and a couple different ways to check some things. You can add more to it, less to it, however you want. Things that may or may not be applicable to your vehicle. Again, I'm going to keep referring to it as Jeep, but I'm using the term Jeep as all-encompassing to include whatever vehicle you may be driving. When you get done with critical components, I call them, which is your chassis and powertrain, then you can move on to things like communications, making sure your CB antennas are properly tuned and grounded. Those are things that, you lose a ground on a CB and you think that's not catastrophic, and it really isn't, but you're going to be out on the trail and there's going to be miscommunication with people. Other people get frustrated when somebody can't hear them or gets lost from the group, and to go even one further, you start having grounding issues with antennas. It can back up the heat and take out transistors, and now you've just trashed your nice new Cobra CB or whatever. So again, things don't fix themselves. Things don't get better. They get worse when they start failing. So just kind of keep that in mind. Now, when I pull my Jeep in, and I know I'm going to be doing a checklist on it, a quick pre-trip inspection, let's call it. I'll pull it in. It'll be up to operating temperature, because it's usually when I come home from work. I'll pull it in the shop. I pop the hood open. I want to check a couple of things. First being my coolant level. You have a surge tank. Now mine's going to be different because I've got a 6.2 liter LS engine in mine, so it's not going to be the plastic bottle that's mounted on the fan shroud. I have a stainless steel surge tank. It's a little bit smaller, but I know my vehicle to where when I take that cap off, when that thing's at operating temperature, I try to keep it about an inch below the overflow tube. I do that to allow for a little bit extra expansion, and also when you're off-road, you're coming down off a rock or off camber, I don't want that thing pissing coolant out on the ground. It's embarrassing, and I don't want anything dripping down off my chassis. If I see a leak or something underneath there, I want to think, okay, something's wrong, not, oh, it's just I overfilled my coolant bottle. Then I'll, a lot of times the next morning after that coolant has been pulled back into the radiator from the expansion tank or the surge tank, I will check the coolant again. That's also when I check my oils and so forth, but I'll check, or my engine oil, but I'll check that coolant level again, and I know where it's supposed to be on a cold engine. Transmission fluid, I'll usually check that at operating temperature. Same time I check the coolant when I pull it in the shop. You want to check that in either neutral or park. Make sure you chock or set the emergency brake. Good time to check your emergency brake, make sure it's holding. That's something that people don't use a lot. I exercise mine quite frequently, but there's a lot of times people don't use them until they need them, and then the cables are seized up or they just don't work, they're out of adjustment. So those are all good things to check, and you can do those systematically without really adding any time to your inspection. So let's go over to the bench and we'll kick this off. Okay, so this is where knowing your vehicle is going to pay off. You pull your vehicle in, it's sitting on ground level, and you want to check your suspension bushings. Most Jeeps have what they call rubber encapsulated bushings. This is just an example. So you've got a steel ring, you have rubber, and then you have a sleeve that is encapsulated in rubber inside. It's vulcanized to that inner sleeve. So that inner sleeve does not rotate in that assembly. Now it's paramount on these bushings that, number one, you check them and torque them at ride height with the sprung weight sitting on the suspension. And also, if you're performing work on your vehicle, you are taking your suspension apart and putting it back together. You need to know what you can tighten while it's off the ground and what has to be sitting with the sprung weight sitting on it at ride height. The reason being, let's just take, for example, so you've got a couple different kinds. You've got a rubber encapsulated. Some aftermarket companies will have polyurethane bushings that have a rotating sleeve in them. Some of them will have a vulcanized higher durometer rubber with a steel sleeve in them. And then you have something more like this is a Johnny joint, for example. This has a uniball inside, a polyurethane surrounding membrane, and when it's bolted and secured in place, it is sandwiching, the forces are being held on either side of that bushing, so it holds that center sleeve solid, but it still allows the joint itself to flex and move about. This one obviously is still, I just rebuilt this one not too long ago. It's sitting on my shelf as spare parts, but so it's not moving very easily, but with the weight of the vehicle moving through its motions and everything, with that weight, with that bracket sitting in there and being tight, it's holding that steel sleeve, and it will allow the suspension to move in a much greater range. So you can tighten a Johnny joint type suspension up in the air, on the ground. It really doesn't matter, because you're tightening onto that center uniball or that center sleeve that is taking all the force, but it is still allowing that ball to completely, you can spin this 360 degrees around, and it's not gonna bind up. So you can tighten those at any position. So that's why I'm saying it's important to know your vehicle. If you have these, you know which ones you can and can't tighten sitting on the ground or off the ground, and which ones have to be tightened with it sitting on the ground. If you have rubber encapsulated bushings, you want to tighten those. When I do any suspension work, I'll set the vehicle down with these bolts loose. I mean, they can be assembled, but just not tightened. And then I will actually jounce the suspension multiple times and get them to kind of take a seat, then go through and torque them. What that does is that centers, I'm going to use this for demonstration purposes, but that centers, so let's just say, for example, this is a normal angle of this is your axle end, this is your frame end of let's say a control arm. That's sitting at ride height. Now when you go over a bump, this is going to go up and compress and rebound. When you're flexing out, this is really going to droop out, or at full stuff, this is going to shove it clear up into your fender well. By having that, what we call a neutral position, meaning that bushing is relaxed state, when you tighten those fasteners down at ride height, it allows that to move equal amounts in each direction. Now it may not be as, well, not may not, it won't be as much as a joint like this, but it will move in the range in which it was designed for. Now let's say you've got the frame up on jack stands and you've got that suspension hanging there loose like this. Now you go ahead and tighten all these fasteners up, then you set it down on the ground. So picture this center sleeve not moving, not rotating in the rubber. So now, as you're setting it down on the ground, it is literally trying to turn that inner sleeve in that vulcanized rubber, that encapsulated rubber bushing. So when you get to ride height right here, this bushing is already under tension. It's not in what we call a neutral position. It is already under tension. So any more upward travel, you're going beyond the limits of what that bushing was designed to carry. So that's why it's imperative that you, number one, when you're replacing these, you center them before you torque everything down. Number two, you know your vehicle to know what you can inspect and tighten and adjust or whatever on the ground, what you must do on the ground, and what you can do in the air. So I have a combination. I've built my suspension under my vehicle, so I know specifically what I have. I have Johnny joints at the frame. and I have rubber encapsulated at the axle to allow for less vibration transfer through to the chassis, because I wanted a compromise between flex and ride quality and durability. So I was running into problems with a store-bought suspension, an aftermarket suspension system that they had proprietary bushings, and I was going through a set of bushings about every 13 to 15,000 miles. So I was replacing bushings once a year, and they warrantied them for the first couple of times, and after that they said no more, and that's when I said, okay, no more, I'm going to build my own suspension. So I went ahead and built my suspension with Johnny joints at the frame end, and the OEM TJ, a little bit larger, but rubber encapsulated bushings at the axle end, and that allows me some nice travel suspension, but I know my vehicle. I know that I check those axle bolts, torque on those at ride height, and I will check them for play, everything down at ride height. Then I'll go ahead and I check certain things at ride height. Then I go ahead and rack the Jeep, get it up in the air where it's comfortable. I can stand underneath it, and that's where I'll check all my torque on all my other fasteners. So that covers joints. Well, it covers joints somewhat. Things like shocks that are usually in double shear, joints such as this, suspension joints that are in double shear. Double shear meaning you're going to have a bracket on either side, meaning there's two shear points for that bolt. Single shear would be if I wanted to bolt this to a plate and I just drilled a hole and bolted it through. That bolt is in single shear. That is not the strongest way to do things. I see a lot of hydraulic assist rams being mounted in single shear. They work, but personally, I prefer to put things in double shear as much as possible. Now, when you're doing that, fastener selection is critical. You don't want to use cheap bolts, but you want to make sure you use adequate clamping. So there's some. You grab a different bolt. Okay, here. So take for example, I've got three bolts sitting here in front of me. One's bolt bought just from a regular bolt fastener company. I can't tell if that's a Lake Erie. Can't tell. Anyway, this is just a set. Now these are different sizes, obviously. This one's a little bit smaller, but you'll notice there's a shoulder and then a threaded portion. If I was to say put that through that fastener, or through that rod end, you're going to see that the shoulder will support one side, but over on this other side, I have threads coming through. What do I have over there? I have a bracket. So this bracket, where that bolt goes through that bracket, it's going to be shoulder on one side, which is smooth, and a little bit just slightly larger, and threads on the other. Those threads will end up destroying that bracket on that other side. Those threads there's just not the surface area, so they will literally act like almost like a file, or probably like a file, and end up enlarging and destroying that bracket. So when you're looking for fasteners, make sure that you utilize fasteners. They call this a grip range or a grip load, and I refer to it as a grip range because it's a dimension, and then a thread range. You want to make sure that grip range is long enough to go through the bracket, the component that you're fastening, the other bracket, and then the threads start. Now, I like to go even one step further and put that and measure that shoulder, and I'll measure that, let that shoulder come out just barely outside of the other bracket. You want that shoulder length to be the proper length. I will usually come through the bracket, and then I will throw like an AN or a mil spec, or even an SAE washer, which it holds a tighter ID tolerance on there, and that will usually cover that slight taper between the shoulder and when the first thread begins. Then you put your nut on, and when you fully tighten that down, I prefer to see 1 to 2 threads max sticking out past your nut. Whether it be a nylock, a stove nut, which are the crimped ones, flange nut, whatever you're using, I like to see 1 to 2 threads maximum sticking out past that nut. So I will trim my fasteners down to get to that that dimension. So, and if you can go to the hardware store and buy these, you just have to buy them longer to get the shoulder length you need, and then you have to cut them down. I prefer to order mine. I ordered a lot of fasteners through McMaster Carr because I order them quite a bit for projects I have going on in the shop, but also because you can order AN, which is Army Navy, or mil-spec bolts, and you can order them by the grip range, the grip length, and the thread length, and also you're getting a better overall quality bolt. An AN bolt is going to start at about 100. It's going to be about 120,000 psi tensile strength, whereas a good grade 8 bolt is going to be 108 to 110, I believe it is. Don't quote me on that, but it's going to be a little bit less. When you start getting down into your grade 5s and your those don't belong on suspension components. So I don't know if this is coming from my racing days or what it is, but fastener selection, fastener length, shoulder length or grip length, things like that are kind of some of my pet peeves. So I tell you this because if you have threads riding in that outer bracket, you will destroy that bracket in short order, and the cost of replacing that bracket are far going to exceed what you'd have spent on a good quality fastener to begin with. So keep that in mind with fasteners. Last thing on fasteners, once you torque them, and yes, you do torque them. Bolts all have specific torque, and you want to torque them to their respective amounts. Once you do, and you'll see when we go around my vehicle, around under my Jeep suspension, you're going to see, I'm using yellow on mine, but you're going to see marks that go across the head of the bolt and then orientate onto the parent material of the bracket. Those are, I just use a regular paint pen a lot of times on my suspension. I use Markall. It's just a paint marker. You shake it up. It mixes up the paint really decent. It's a felt tip on this end. You push it a couple of times and it saturates the felt tip with whatever color of dye is in the marker, this one being yellow. Then you just drag it across, starting from center. You don't want to go all the way across because it doesn't give you a reference for that head. I usually start just off center and go across the head of that bolt and then onto the parent material, usually about the same distance. What you want to look for is you want to use this as a quick reference to where, and I'll do this while we're at a rally or a gathering and we come back from a trail and I've washed the Jeep up and it's all ready to go for the next day. It's fueled up, everything ready to go. A lot of times while the wife's in the motorhome getting ready to go to a happy hour or whatever, I'll just do a quick visual, the flashlight, I'll go around and hit them, and I'm looking for anomalies. I'm looking to make sure those marks line up. If I see one that mark is, 45 or 90 degrees off on the head of the bolt compared to the mark on the bracket, that fastener is moved, that fastener is rotated, so it's obviously loose. So it's just a good quick visual indication that something has moved there. So I'm a big proponent of paint pens. Maybe it's from my racing days again, I don't know, but I use these on a lot of fasteners, specifically on Jeeps, off-road vehicles. The other component I use is, this is made by Dykem, I believe. Yeah, Dykem. I've called it I usually refer to this as torque seal. They're calling it cross-check. Again, I get this from McMaster Carr. I just usually refer to it as torque seal. So I use paint pens and I use torque seal, and I use them for kind of the same thing but different. So torque seal is going to think of it like a hard drying, smaller bead of silicone, but it's not rubbery. It dries hard, and so you put it over the head of a bolt, and you put it down the side. You put it on the nut of a bolt and down the thread and across the center, the part of the bolt, down the thread and over the nut. I specifically use these on brake components because they'll hold up to the heat really well. So like your your bolts where they bolt to the brackets to the knuckle, where your caliper bracket bolts are, I will put a small, and this is like an 1/8 inch bead, but it'll cover over that area. When it dries hard. If that fastener turns, you'll see this will appear cracked, crumbled, broken. It's a quick visual indicator that fastener has moved. Brake components in particular, you want to pay attention when you're taking things apart. If you have any fasteners as you're taking apart that you're putting a ratchet on things, you're going to know that, ooh, that one's a little loose compared to the other side that I just did. That should be your first red flag. Something has come loose. You need to find out why. It could be that it wasn't torqued properly to begin with last time, or it could be that something is either failing or has failed and that bolt is either stretched, shearing, coming out, something. So those are just warning points. But again, I like to use paint pens on all my suspension components and whatnot, and I'll use the torque seal on brake components, mainly brake components, or areas where I have a nut that I want to look at, sometimes more in particular than just the head. So I'll actually drag this torque seal over the threaded portion, down over the thread, over the nut. So again, they both kind of serve the same purpose, but they're slightly different. These are cheap, they're inexpensive, and it gives you a good, quick visual representation of what's going on with that suspension. So, okay, that's enough of me yammering here at the bench. I'm going to grab a flashlight, a creeper, and a pry bar and show you some basic tests on your suspension components on the ground before I go ahead and rack the Jeep and show you some additional stuff. Okay, so for example, here I've got my lower control arm bracket and my upper control arm mount, lower control arm. So you can see that I have paint markings where the jam nut goes to the actual control arm link, the bolt to the parent material on the bracket, the bolt head to the parent material on the bracket. So those are what you want to kind of look at. Lower control arms at the frame end are 125, they get torqued to 125 foot-pounds. The ones at the, at the frame end, at the axle end, I believe they're 117-ish, right through there. Upper ones are all 75 foot-pounds. So I crawl underneath, I start looking at those indicator paint marks, everything looks good. I go over and look at the axle end, everything looks good there. Then I go one step further. Now this is with it sitting at ride height, but I will take a pry bar and put it up between the bushing, hopefully that'll help that a little bit, between the frame and the bushing. Now again, this is all custom bracketry, so yours is going to look different, but you'll put it up in there and you'll be careful not to put it on the grease zerk if you have grease zerks, but you want to rock this fore and aft. And what's that going to tell you is you have that, this is a Johnny joint, so it's going to have that sleeve sandwiched between these brackets. Any movement in there is going to be the bushing wear, not the sleeve. So what you don't want is, you basically don't want any slop, any play. So by taking a pry bar and moving that different directions, this is solid. So that bushing is still good. I will do that with each consecutive. That one's good and tight, and I'm getting grease on my pry bar because I've had these grease last service intervals, so, which is good. You don't want to see them dry. But I will go around each joint on my suspension. So I've got basically 4 at each corner, 2 at the axle, 2 at the frame on a 4-link setup. I will check those at each corner, and those are really the things you want to check at ride height. The other thing you want to check at ride height, and we'll go around to the front here, is the track bar. The track bar is the other one because it's going to have a bushing of some sort connecting the frame to the axle, and that's where you want to also, it's going to be the same relationship as I showed you at the bench with the bushings. So as the chassis, as the axle goes down away from the chassis, that bushing is going to rotate as that axle goes through, moves through its motion. So let's go around to the front. But this is how you check all of your suspension components, and then throw a torque wrench on them. If anything moves, or is loose, you want to wipe the paint, and usually brake wash or acetone, something like lacquer thinner will take this paint marking stuff off and then just remark it and go on. Or if you're pulling components out to replace something, I'll clean the paint pen markings off, and then as I put it back together, retorque everything. If I see something, that's usually the final step, so it's an indicator to me. If I don't see a paint marking on that, I haven't torqued that to spec yet. So I'll hit it with the torque wrench, torque everything, and then I follow right along as I'm going with my paint pan and mark them. That way I know that that fastener is torqued and sealed for rotational observation down the road. So let's go around to the front axle real quick. All right, so here is front steering. We're looking at the same thing here. This is going to look a little different than many of yours probably. It might look the same as other ones, but it's not factory. So here, point to it. Hopefully this will show up. Right here is the fastener for the axle end of the track bar. It's going to have a bushing in it that you want to check, and you can see I've got my paint markings on it. Everything looks good there. Check everything there, it looks good. Then they have another one at the frame end, the same thing. You're going to want to check that as well, and it looks good and tight. The paint markings are good, hasn't moved. You've got your drag link. You're going to want to make sure that's in good shape. Again, paint markings on all my fasteners. Here is my hydraulic steering ram. Again, paint marking on all my components. Make sure from the jam nut to the rod end over here that is in double shear. Let's see. Oh, one other thing. This is where bump steer comes in. When you're looking at this, you want to draw an imaginary line from the pivot point at the frame end of your track bar to the axle end of your track bar, and your drag link should be parallel. That's how you eliminate bump steer. If you have a factory mount, and like I've got a flipped drag link here to get it up high out of the way, so I've got a good 1/4 inch thick bracket that I've fabricated and welded onto my axle, and for two reasons. Number one, to provide a thicker area for that fastener to go through compared to the stamped steel one that fails at a regular basis on stock Jeeps, but also because I need an attachment point for my hydraulic ram. So I've beefed up my axle end here substantially to handle both the hydraulic ram and the track bar. Now, what I've done on other vehicles, on vehicles for other people that maybe have just noticed a little bit of wear, but they don't want to go through the expense of putting a new track bar bracket on, I've welded what's called a doubler on, where I just take a washer, a machined washer. Let me put it that way. You can do a regular washer. I like to machine one out of like 8620 or even 1045. It's a higher carbon steel than regular mild steel that the brackets are made out of, and I will weld that on, and basically what that does is it gives you a thicker mounting area for that bolt to go through. Remember I talked about having a shoulder bolt, the shoulder of the bolt go through that? That gives you more surface area than just that. Say a 10 gauge is like 120 thousandths. Now you've added a 1/4 inch thick washer to that, and now you have nearly 3/8 of an inch of thickness for that, to spread that load out, which also brings me to the fastener side. If you've got a shoulder bolt that's going all the way through that and your threads are coming through, you can throw like an SAE or an AN washer on there that's going to measure anywhere from, a regular washer will run anywhere from 60 to 75 thousandths thick, but you use like an AN or a mil spec washer, you're talking anywhere from 75 to probably 120 thousandths thick washer. So that allows you to increase, you can run a longer shoulder to make sure you capture the shoulder in both of those brackets, and then you don't have to worry about bottoming out on the threads before you actually tighten that grip range on that fastener. So you can run a washer at either side, or I generally put them on the nut side. But if needs be, you can run one under the head of the bolt and the other. I'll give you, figure 120 thousandths in each one. That's almost 1/4 of an inch that you can run if needs be, so you don't run out of threads while you're torquing your fasteners. So anyway, everything here looks good. All my paint lines are looking good. Tie rod, drag link, everything's good. All my fasteners are tight where my hydraulic ram is secured to the tie rod. That is another area that I see a lot of failure on, and the hydraulic ram will start sliding on the tie rod. At that point, you're not really assisting anything. You're just grinding that bracket back and forth on your tie rod. So that's critical as well. At this point, I'm pretty much done at what I do on the ground. So let's go ahead and rack the Jeep, and I'll show you what I check with it up in the air. Okay, before I rack the Jeep, I just want to show you a couple of things we want to look for underneath the hood. Battery terminals. Give them a little tug. Make sure they're tight. Winch connections as well, but make sure everything's good and tight. One thing I like to do on electrical connections and so forth, especially around the battery, is I will actually wait till dark, fire up a vehicle, turn off the lights, and I'll go in and I'll just start grabbing a couple of wires and moving them around the battery. If you have any kind of loose connection, it'll be like the 4th of July in there. You'll be surprised at how quick a insufficient connection shows up. It shows up rather easily. So things I look for there, I want to look at my hoses. I want to look at the connections on the spigots, on the radiator, the engine. Look for signs of crusties, as I call them, the coolant that's escaped. I also want to look at my accessory drive belt. I want to make sure it's not rubbing anywhere. I want to make sure that it's not cracked. That's one of those maintenance items where if you're tracking your maintenance properly, you'll kind of have an idea of what service interval to change that at. I'm a big proponent of changing parts. In my opinion, everything has a expected life expectancy. Part of what I've done for many, many years now is reliability engineering into everything that I've built. Maybe it's kickback from my days as industrial maintenance mechanic, I don't know which, but things have failure points. You want to change things out before they hit that failure point, because they're so much easier, cheaper to do in the shop than they are on the side of the road, or worse, out 25, 30 miles in the backcountry when you don't have the luxury of the parts. So things have a designed life. I'm a big proponent, again, of changing those components when that life is near its end. I don't want to wait and be reactive. I want to be proactive. Preventive maintenance is just that, preventing failures. So that's, if anybody who knows me is going to know, that's one thing I am anal about, is preventive measures, preventive maintenance. I don't like doing things reactively. So anyway, check everything over, check connections. I've got obviously computer connections in here for the ECM. Jeep has them down over here. You want to make sure the little locking tabs are locked in on them. All your bail connectors, like your C100 back here, your C300 down on the chassis, all those bail connectors have got barbs on them that fit into brackets to keep them secured. If those come loose, that's a lot of weight on that plug. It will bounce around there until you either gets caught in something, falls down and touches on the exhaust and melts wires together into a big blob, or the wires going in and out of that connection sit there and fatigue so bad that they finally break. Now you're trying to chase an electrical gremlin in a plug with 30 wires per side, so it can get kind of hairy and troubling trying to troubleshoot something like that out on the trail. So make sure those bail connectors are clicked, latched, and that they are secured in their respective brackets. Same thing with relays. You'll notice all my relays for my auxiliary lights, all that, they are secured with fasteners. They're not just hanging there. all my wiring from both OEM and from my engine swap are all tied up properly so that I know what normal looks like. If I pop the hood and I see this wire loom droop down in here and it's melted in heat, that's a visual indication right away that something's not right. So you want to look at things, you want to know what normal looks like. Look at wires like around your alternator, your charging circuit. While you're under here, now's a good time to check, clean, and or replace your air filter. Windshield washer fluid, that's a big pet peeve of mine. I can't tell you how many vehicles I work on that the windshield washer bottle is empty or near empty. I don't want my wife to ever have to not have washer fluid in her car if she comes out of a dirty rainstorm. To me, that's a safety factor. And when we're off-road, I want to make sure I leave with a full bottle of windshield washer fluid to be able to keep my windshield clean so I don't end up in a ditch or on my lid somewhere because I didn't see a turn. So things like that you may not think about, but you need to train your mind to look for those things. And then you'll get to the point where you're so used to looking at them that when you pop the hood and you see something out of the ordinary, your eyes are going to immediately be drawn to it. So that's where I said earlier in the very first of the video, you don't need to be an ASC certified mechanic. You just need to have a personal relationship with your Jeep so you know what normal looks like and you know what abnormal looks like. That's what you want to correct before you go out on the trail. Nobody wants to go out on the trail and have breakdowns. And to be honest with you, people don't like wheeling with people who continually have breakdowns. So I can attest that we have actually quit wheeling with some people because it seemed like every time we went with them, they were breaking down and wouldn't really do anything to help the situation. And you know, the Jeep community is great. When you have a breakdown or a failure, people will go out of their way to get you off the trail. But you do that to your friends time and time and time again, pretty soon you don't have any friends to go wheeling with because they're tired of fixing your crap. They went out there to wheel, not work on your stuff. So keep that in mind. It's be respectful of not only yourself, you're respecting your vehicle, but you're respecting the group you're going with. So that's one of the reasons why I like wheeling with the group that I do so much, is we all know each other really well. We all spot really well. We all have similar driving styles. We all have similar tastes and trails we like to run, and we feed off each other very well that way. So I will drive from here to South Dakota to go to attend a rally with friends that I know I can wheel with because I know how they are to wheel with. All right, so I've checked all 16 of my joints for torque and play. They all look good. So now we're raising the Jeep up. Now this is where you have to get the front end up off the ground. Sorry, this is where you have to get the front tires up off the ground so you can check your ball joints. This is not difficult to do. What I like to do is get it 4 to 6 inches off the ground, and then I'll take a large pry bar, slide it underneath the 6 o'clock position, put my hand at the 12 o'clock position, and I'm going to slightly lift and rock and see if I can feel any play in it. There's no play in it, then I'll usually grab. Now this is a little harder because you're trying to turn the other one, but you'll be able to tell. You'll actually feel a clunk if you have a tie rod. Now's a good time where I'll usually just kind of take a flashlight, poke my head in, and I want to look for things like the coil buckets. I want to look at where those are welded onto the frame. I want to look. This is where it's a good idea to keep your frame painted decently. So when you see a crack in the paint, that's usually a crack in the weld. So looking over here at the shock towers, same way. Now I do need to rebuild my shocks. I've got some Fox oil on the bench over there, so I need to break those down and rebuild those and recharge them. That's another project that I've got. This video is just on the inspection. So you want to check your frame mounts for your sway bar. Now I also have brackets for my toe points, because I flat toe this behind our motorhome, so I inspect those welds very thoroughly, and I keep those painted up as well. They tie in from my bumper to my frame to my lower cross member for my tow bar. So I'm looking at all those. I'm looking at all the components. I don't see any wear at any of them. You want to check your sway bar links, make sure those are in good shape. I did pull my spare tire off because I do 5 tire rotations, so I pulled my spare off while I was sitting down on the ground, so I don't have to be a Hercules and lift it from 3 feet off the ground. So some of this stuff I will check once I get the tires off. Things like brakes, and then I'll actually go in and grease those and everything too. But things that you can check just with a flashlight. And again, if you know what normal looks like, you're looking for things that are just out of the ordinary, out of the normal. I look at connections. I go as far as even look at connections on my lights. Make sure all those are in good shape. The wirings, I got the wires held with the dowel clamps up here to the body, up out of the way to keep them away from the tires, obviously, but away from anything moving, and just to keep making them look nice. Also, keep them so they're not hanging down across the bumper, chafing on the edges. That's another big thing I look at, and actually, I'll show you when we get underneath here. I'll show you what I do for abrasion resistance in some areas. So. Okay, I'm just going to go ahead and get it up all the way. Okay, in the air. So let's see if we can get a little better view here of the underneath. So, all right, so if you notice, here's my hoses for my steering. I actually take a heater hose, cut it, slice it down the middle, wrap around, and there's a metal crimp fitting here to keep it from wearing into the steel braided hose. I wrap around there and put a tie wrap, a zip tie, whatever you want to call it, on there. So I do things like that for abrasion resistance. And then I look at anything. A lot of times you want to look for things that are shiny. You know the old saying, shiny object? That's kind of what you want to look for. If something's been wearing or rubbing on something, a lot of times it'll be shiny. It'll be worn down to bare metal. So looking at all my joints under here, everything's looking good. I will exercise and sometimes spray a little bit of fluid film on my sway bar disconnect. I have an Evo manual disconnect. I took this Rubicon sway bar actuator off a long time ago. That was one of the first mods I did. I want to look up underneath at my motor mounts, make sure everything's good there, make sure nothing's moved. Other things I want to look at is my limiting straps. I want to make sure those, check the paint marks on them, make sure that where the limiting straps go through the metal clevis at the end, that there's no fraying going on. I'm a big proponent of limiting straps. I don't like using the shocks as your limiting straps or your bump stops. So make sure your bump stops are properly set. And sometimes most of the time, if you want to get full suspension travel, I recommend you do tests rather than just rely on what comes with a suspension kit. I don't have per se a suspension kit on mine. Mine's all onesie twosie and custom made. So I've spent a lot of time getting my bump stops and my droop set and adjusted. So again, I don't like using the shocks as limiting straps. That's one of the reasons why my shocks probably last so long, is because between service intervals, is because I'm not using them as limiting straps. Another thing you want to look at, brake lines. Can't tell you how many times we'll be sitting there watching an obstacle, watching somebody going up an obstacle, and they flex out and the brake lines are pulled taut. It's like, ooh, that's your limiting strap right there, is a brake line. That's what you don't want. You don't want to have a brake failure, because what goes up has got to come down. And if you're going up an obstacle and you lose a brake line and you got to come down, you're not going to have any brakes. Other than that, this is where you have to know your vehicle. I'm looking for things like, I'm looking at my exhaust manifolds. Again, this is an LS V8, so I'm looking at my exhaust manifolds up there, and I'm looking for carbon tracking coming out of the gasket area. I'm looking for fasteners that have come loose. I will actually About once a year, I will actually throw a wrench on the fasteners and just double check and make sure they're tight. Let's see, again, motor mounts, belts from the bottom side, make sure nothing's touching the belt train. My AC belt on this GM motor is a stretch belt, so I make sure and keep an eye on it and check it over, and it looks good. And then the Serpentine belt, the accessory drive belt, goes up through the Jeep drive accessories. Let's see, transmission cooler lines. I have compression fittings coming off from the 6L80 forward, so you want to make sure you check things like that. You want to look for at them for leaks. And the leak may start out as just a wet spot, and as it tracks dust. That's another reason I don't generally wash my vehicle before I do a pre-trip inspection, because if you have a slight leak, it will show up in dirt, dust, things like that. Whereas if you go through and pressure wash the undercarriage and everything right before you do an inspection, that's going to be harder to see those leaks and those anomalies. So I usually wash it after I do the inspection and everything. I'll wash it usually before I hook it up to the motorhome and head to a gathering or a rally. So everything's looking good. I don't see any wear marks anywhere. I'll turn rotate the tires and wheels, listen for anything that's dragging, pebbles in the brake rotor, dust shields, a bent dust shield. I've had vehicles where I've had them on the lift and I've got a tinny sound and checked out, and sure enough, they had hit something or got a tree branch or something caught up in there to where it had pushed that dust shield into the rotor and created an interference. So looking good back here. We'll go, and also I've got the even on the track bar adjustment here, I've got paint markings on them, so you can watch for anything that might come loose. All right, rear, kind of the same thing. I'm down against my limiting strap. Now, granted, I am going to put another 1.5 inch longer limiting strap, but I've got plenty of brake line here because I've raised I cut my old the OEM shock mounts off, built some out of 1/4 inch plate, and I've raised them up so that they're not hanging down below this mount. Evap canister, everything's good there. Exhaust, bump stop adapters, limiting straps there again. You want to make sure that there's no fraying or anything on them. The bracket for your rear track bar where it welds to the axle, I've got mine gusseted. I've taken the OEM one off and I've built one out of 3/16 and 1/4 inch plate, and I've gusseted it, and where it goes up and ties up into the chassis. I'm going to check that chassis. I saw one of those get ripped off last year in South Dakota when we were over there. Saw a guy that had his ripped clean off. Everything's looking good under here. Wiring tucked up nice and tidy out of the way. Either zip tied, tie wrapped, or use the little Christmas tree barbs to hold your wiring up in place. Emergency brake cables, make sure they're not rubbed through anywhere. Make sure everything's good. Okay, I think everything looks good here. This would be a good time to grease everything while you got it up in the air or around jack stands where you can get your grease zerks to take grease easier without tension. All right, there's a couple things I want to touch on the front of the Jeep here. One of them is your winch. You want to make sure that winch is ready to go at any time. You never know when you're going to slide off the road. You never know when you're going to come around a turn and there's going to be somebody else who slid off the road that you can help. So you want to make sure it is, number one, you've got a reliable winch on the front of your Jeep to begin with. Don't just throw a winch. If you plan on using your Jeep off-road, which if you're watching this video, I hope you're planning on it because that's the things I'm trying to teach you to inspect. But use a good quality winch. Don't just throw one on there because you think it looks cool. Make sure you're using a good winch and make sure you test it periodically. The contacts and so forth in them should be exercised on a regular basis. I don't use mine a ton. I've used it more on helping other people out than on myself. And I still pull it out at least once, sometimes twice a year. my driveway outside my shop here going out to the street is on a very slight incline, so I will string it out, hook it to my son's Jeep or something, and roll it up, and just make sure to check everything, make sure the cable's not twisted or bound. This is a wire rope. You've got some synthetic rope that is also, we won't even get started on the whole debate between synthetic rope and wire cable rather. That's a debate that's going to go on until the end of time. I'm choosing to run steel wire cable on my Jeep. My son's running synthetic on his. So it's a good time to stretch those cables out before you need them. That way when you have confidence, and that's the whole point of this, video, is you want to have confidence in your vehicle's abilities to get you out to the backcountry and back, and then whether it be to work the next day or whatever. If it's a toy, then you park it and you want to have confidence that it not only got you out and back on that trip, but it's also you're confident that it'll get you out on the next. So, but anyway, I run mine out a couple times, at least once, sometimes twice a year if I haven't used it, and make sure to pull it in and wrap it properly. Also, you want to check the bolts. That's a common overlooked item. A good rule of thumb is on the 3/8 fasteners, you want to be around 30 foot-pounds of torque. On 7/16, I think they're around 50. And on half-inch fasteners, they're 75 foot-pounds, I believe. All those specs will be found in your owner's manual, installation manual. Mine happens to be a Warren. Others, you also have to check your particular brands and synthetic check the torque specs on it. There's an added maintenance you need to do on those, particularly if you drive in foul weather, which nobody can not get caught in foul weather. It doesn't matter whether it's on a wet gravel road or a winter road where they, sand the roads. The debris, road spray, things like that can get up and get inside the fibers. I've seen 3 synthetic rope failures in the last 2 years. 2 of them, I believe, have been due to being cut from the inside out. One of them was a little more worn than the other, so I think it was probably a usage. But that particular failure, it looked like the inside was worse than the outside. So what happens is when you drive through road spray and so forth, those get up inside the fibers. Then when that cable is pulling and giving, those sand, gravel, whatever it is in there, acts like shards of glass and just starts cutting those fibers inside. The other failure I saw was the bumper opening was smaller than the Haas Fairlead that was on it. So when the when the synthetic rope would come out, he was pulling on just a slight angle, but it was chafing on the bumper, never even touching the Haas Fairlead, and it ended up slicing and cutting. And it was a brand new rope. It looked like a fairly brand new winch. So that was more the opening of the bumper, but it should have been noticed when the Haas Fairlead was going on. Now I'm running a roller Fairlead on mine, but I still made sure when I fabricated my bumper that the opening was larger than the Fairlead. So if that cable comes out of there, it's never going to touch the bumper. It's just going to touch the rollers. You want to make sure when you have a Haas Fairlead, it's the same way. You don't want the synthetic rope to touch anything but the smooth radius of that Haas Fairlead. But when there is maintenance on the synthetic rope, and I would like to incorporate that into the inspection on this. My son's running a Warren Xeon 10S with a synthetic rope, and he will take 2 5-gallon buckets of water, one with a little bit of soap in it, and then one just clean water. You want to take that rope and you want to push it together, and when that does it, it opens those fibers up. Then you dip it in and out of the water, and it gets soap and water in there and extracts it. And you can watch it start dirtying the water, and then go to the clean one and then grab another couple foot section. And again, it is time consuming. You've got 75 to 125 foot of synthetic rope on there, and you go a couple feet at a time. It takes a while to properly maintain that. And that's what I want to encourage people. If you're not willing to do the maintenance for synthetic rope, look at the other options and weigh those options carefully on how you're going to use it. Like I said, there's a whole other debate on that, but you want to make sure that everything's properly maintained, whether it's steel wire cable or synthetic rope. Excuse me. Another thing, when you're putting your winches on, your bumpers. Make sure that they clear. Saw another incident earlier this year where the gentleman needed the winch, couldn't even declutch it, couldn't operate the handle because he was making contact with the bumper. When you go through the motions and doing a check and inspection and pulling those out, you'll notice those things. You should notice them at the time of installation, but if not, you're going to notice it when you're exercising them. So things like that, check them out. I also like to have them mounted as low as possible down between the frame rails. That way you're pulling down here in between the frame rather than up here, putting undue stress on it, plus the fact that you're blocking your cooling stack, which leads me to my next point of inspection. Now, I'm not going to go into a big lengthy discussion on cooling because I've got a whole nother video on Jeep cooling, but basically you have 7 louvers in here. Chrysler provides us with 7 louvers. Use all 7 of them, keep them open. Don't block them with those angry grills because that cuts down area. Don't block them with mesh. Keep them open and keep them inspected. I've got a big, thick, heavy transmission cooler here backed by an AC condenser. Another thing to think about is when you have issues with your AC condenser, look at aftermarket. This is one of the very few times you'll hear me talk about supporting an aftermarket product over an OEM. The OEM Mopar AC condensers have a very high fin count. They're very dense. That actually impedes airflow through that cooling stack. So I'm actually running an aftermarket. I believe this is a 4 Seasons. Don't quote me on that, but I'm running an aftermarket one, and I'm running one for a manual transmission because the automatic transmissions have a small transmission cooler in the bottom, and they don't do much. Plus, I've added a big transmission cooler, so I wanted as much cooling surface for my AC as possible. So I put a manual transmission AC condenser in it, but the cooling fin count is a little less dense, so it allows better airflow through because you've got to go through a transmission cooler, AC condenser, and then your radiator before it ever gets to the fan. So keep that in mind. The other thing is you're looking at cooling. You want to know not only your vehicle, but you want to know where you're going. You want to know different areas you will prep for differently. Obviously, you're going to pack different gear inside for different trips. You kind of want to think the same things through with your vehicle. Now, my wife and I's first big trip that's coming up, the reason why that's prompted me to go through and do a major service is Colorado. Anybody who's wheeled in Colorado knows that you are starting at around 8,000 feet and you go 12,000, 13,000 feet routinely multiple times a day. That is hard on brakes. That is hard on transmissions. That is hard on cooling systems in particular because the air is so thin and less dense up there than it is down at lower levels. So you're not expelling that heat through the cooling stack as efficiently as you are when the air is more dense. So there's things to be said about knowing where you're going. This is a big reason why I go through my brakes thoroughly. I pull them apart before this trip and check everything. I make sure everything's torqued properly. I make sure that the glide pins that the calipers glide on are properly lubed and free and nothing's hanging up. I check and make sure that my banjo bolts on the calipers to the brake lines are properly torqued. There's no leaks. I will actually replace my brake fluid. This year I'm due for a brake fluid swap. I do it every other year. On the off years that I don't change the brake fluid, I will test them with test strips because you want to make sure that there's no moisture. Brake fluid is very hygroscopic, meaning it absorbs moisture just from the air. Only 0.1% of moisture in your brake fluid can cut your boiling point in half. That means you're coming down off a Black Bear Pass. Even if the rest of your components on your brake system are good, you're coming down off of that into those switchbacks with nothing but Telluride at the bottom. And if you lose brakes, you boil your brake fluid, you've basically got air in your system, you've got a dead pedal. You're not compressing air, you're compressing, you want to push that brake fluid, so you want to prevent that from happening. So this year it's due for a service. So I will flush I go to the furthest brake caliper and I pull fresh fluid through to it. I want to make sure that I know what I'm prepping. Now, this trip is hardest on my vehicle every year. This is our 14th year going to Colorado. I've learned some things over the years, and I know how to prep my vehicle for Colorado. And then the subsequent trips after that are really nothing compared to Colorado as far as stress on the vehicle. South Dakota, Moab, those trips are just flat wheeling. My temperatures will stay 205 to 212 all day long crawling. My transmission temperatures never get really above 165. My brakes don't get hot because I'm not on them constantly. Now, when we go to Colorado, I'm pushing the limits. That's why I service my transfer case also. I want fresh fluid in that transfer case prior to the climbs and the grades in Colorado. I just did the transmission service and front and rear axles a couple of months ago, so I know my differentials are good. I know my transmission's good, fluid-wise. But again, know your trips, know your potential issues, and correct them, or at least adjust your driving style as you're on these trips. We want to prolong the life of our vehicles so that we don't have problems on vacation, nor when we come back and have to take that now drive back and forth. Again, you want to make sure that you don't have any bent fins. You want to make sure that there's no obstructions. Keep the bugs cleaned out of your grill. Those are things that you can do long before you ever hit the trail, and they're going to pay off big time on the trail. So anyway, I'm just kind of covering some items, and don't get me wrong, this inspection is run longer than I thought it would, but I'm trying to relay as much information as I can. When I'm getting ready to do a pre-trip inspection, most of the time, if I'm going with our local club or my son and daughter-in-law for a day trip or something, I'll usually pull it in and give everything a good visual, check my paint marks and everything in particular, check those things over, check fluids, and then I'm ready to go. If I'm getting ready to go for a weekend trip and just a normal wheeling, I will still do pretty much the same, maybe go through and check a little bit more things as far as the underneath and the suspension points and everything. I usually only do one of these major inspections where I'm actually putting a torque wrench on every fastener and everything, usually a couple times a year. But and so they take a little bit longer. But normally, my process is if we're getting ready to run on a Saturday run with the club, I'll pull it in Wednesday night, Thursday night to give myself a little bit of leeway in case I do find a problem. But I'll pull it in Wednesday night or Thursday night after work, and by the time I pull it in, check coolant level, check transmission fluid, and then visually check all my markings. I mean, we're talking 20, maybe 30 minutes. And then the next morning before I leave for work is where I check the coolant level again and my engine oil. If everything looks good, I know I'm solid for that trail run that weekend. So there again, we're talking 20, maybe 30 minutes at the most for a normal inspection. Don't be thinking you've got to dedicate several hours before you go off road. That's not the case. I've drawn this out just to make sure I cover as much as possible, but that's not necessarily the case. Like I said, for a week rally, week gathering, something like that, I spend a little more time, and a lot of times we'll throw torque wrenches on all my fasteners and everything. If anything moves, I will take the paint markings off, reapply them, but usually nothing moves, so the paint markings can stay where they're at. But that's pretty much what I wanted to cover. I think I've rambled long enough. I was going to make this a short video, but it turned out to be a little longer than I thought. So anyway, I hope this was helpful. Again, I just want people to get comfortable with their vehicles and know what things should look like so that when you see something that jumps out at you, it's a good visual indication that there's something not right. And then also know what the vehicle should feel like when you're driving it, whether it be steering, if you take brakes, it to shop XYZ, you want to be able to explain to them what's going on in a somewhat intelligent manner to make their job easier and also to make sure you get the problem resolved. Otherwise, you're going back and forth with this shop. You end up being a customer that they want to fire, and then you're looking at the shop as maybe they're incompetent, when in all honesty, it's a communication barrier. So that's all I'm trying to do, is just get you to think things through. And we're supposed to go off-road with these things and have fun. And when you have breakdowns off-road, it's not fun. When somebody in your party has a breakdown, it's not fun. So I look at it as I've got a shop full of tools that I want to use to maintain my vehicle. I carry tools in my Jeep, but I really don't want to have to use the tools in my Jeep. The most I want to get in the back for is to get my lawn chairs out when it's time to sit for lunch and everybody's sitting around laughing and joking and having a good time, not wrenching on somebody's vehicle. So please take this video for the intent in which it was made, and I hope you go out and look things over and become familiar with your vehicle. If you like the video, give me a thumbs up, and any comments I welcome, and thank you for watching.